Hello, my name is Santiago Latour, and today I will be presenting on the introduction to the topic of probability. First of all, it's important to state that probability can be defined as the dealing with the likelihood of a certain event's occurrence. This means, as we have in the example, the two dice represents events. And we say, what is the probability that from one dice we throw a 3? Our probability here will be 1 out of 6. Now here we go into the next topic from our key terms from probability, which are sample space, which is all the possible outcomes in the case of the die we have here. We can say that all the possible outcomes from one die will be 6, and as such from a coin being tossed, you can say that the sample space will be 2. Now we can see that the probability of an event is the number of favorable outcomes. In the case we said earlier, the probability of getting a 3, we put the number of favorable outcomes of getting a 3 is 1, and we divide it by the sample space, which is 6. So 1 out of 6 will be our probability. Another important fact to say about this is that the probability of the possible outcomes will always have a result from 0 to 1. This means that the sample space is the 1, like all the possible outcomes that can happen. For example, if we say what's the probability of getting any number from a throw of dice, we would say 6. So that's all the possible outcomes we can get from throwing the dice. And in the case I say, what's the probability of getting a 7 from one die, the probability would be 0. It can never be less than 1 because that would mean that there should be negatives, and while we're doing this, such as a die, we cannot have negatives. Now we can see that all events can be classified by means of certain equations. For example, mutually exclusive events is when events A and B are not common, do not have common elements in between them, and they are represented by the equation. The union of event A, B is equal to the probability of A plus the probability of B. And also we have events that are independent, such as the roulette wheel we see above, where the event that's going to occur does not depend on the event that previously happened. And this one, independent events are calculated by the intersection of A and B is equal to the probability of A times the probability of B. This can also be shown in a deck of cards. For example, it's the probability of me getting an ace, but then we get conditional probability in where each event depends on the event that already happened. For example, if I say, what's the probability of getting an ace in a deck of 52 cards when I already got an ace? So here I would say, the first probability of getting an ace is 4 out of 52, but now after I already took one out of the deck, I only have 1 out of 52. And now we'll speak about the 3 axes of probability, being the first one as already mentioned, probabilities equal or more than 0, that events cannot be negative because all events have to be positive. The second one is that the sample space is always equal to 1, as this is the addition of all the total outcomes, which will give a probability of 1. So what's the probability of getting all of the events? And the third one is the probability of A union B is equal to the probability of A plus the probability of B. Now we'll move to norms apart statistics, where we treat the mean, median, mode. Mean being the average of a set of data, the mode being the repetitions from a set of data, and median the middle number. Now we see a normal distribution, and it's used to represent the real valued random variables, and we have to state that from the graph we have above, we can say that the area under the curve is always 1. There are 2 lines that represent our standard deviation, which is how close the data is to one another, and this is given by events that do not have to be independent, unlike binomial distribution, which only treats independent yes/no events, and it treats the number of successes these events can have based on parameters such as NMP. Thank you for watching. This is probability.